Hello everyone. My name is Sohaib. I'm happy to have the opportunity to present to you the implementation of the FLUTE protocol inside GPAC. Since this is my first time here, I'm Sohaib Larbi. I've been a software engineer since 2018. I mainly worked on C and C embedded projects before joining Motion Spell. I've joined Motion Spell on September 2023, so it's been a little above a year right now. And I worked mainly on multicast ABR technology and also on the API of GPAC and testing and approving tests in general inside GPAC. GPAC briefly is an open source multimedia framework. It's been here since 1999, open source since 2003. It has a lot of capabilities and use cases that and a valid community that maintain it. Motion Spell, which is the company I work for, offers professional service and consulting training around GPAC. Also, it's the exclusive commercial licensor for GPAC. So in this presentation, what I'll do is I'll be briefly presenting the GPAC architecture just to have just to know for those unfamiliar to know what's GPAC. Then I hope you will permit me to add context to the presentation by presenting Flute and what's its main feature. And mainly I will present a demo and talk about an example of Flute inside GPAC, which is the DVB MAPR spec implementation inside GPAC. Which we implemented. Let's start with that. GPAC, the main points that I want here to explain is that GPAC is modular by nature. We have what we call filters. Filters can be anything, can be processing unit, also can be media consumption, media input, which is like filter input and filter output. Those filters are configurable and they use which we call PID, which is data channels to communicate. Each PID has its own properties that describes the data that it contains, weight, like width, height, codecs, etc. Properties can be built-in or user-defined. The PID can track its properties and even reconfigure them, which allows for filter chain reconfiguration or even dynamically reloading the filter chain. GPAC is highly capable. It has a lot of support for media standards and formats, and also extensive libraries, codecs, filters, and protocols, which makes it useful in mainly most of multimedia tasks, playback, streaming, packaging, transcoding, media inspection, etc. We also have customization, the possible customization, which mainly you can create your own custom filter, and also we provide an API in C, and that you can include GPAC in your code. Also, there is wrappers in Python, JavaScript, Node.js, etc. Next I will go to FLUTE. FLUTE is a unidirectional transport protocol. It inherits everything from ALC, and it adds some features for ALC. The purpose is to have reliability and multicast by unidirectional delivery. The main feature added to ALC is the FDT mechanism, which is a mechanism for mapping between objects or files and their between files and their object. And the reliability comes from certain features. As I said, FDT, also FAC, and session management. Fluid reliability also, like the mechanisms that are present in, also I said, is the FAC. Also there is retransmission of data by carousels that typically used for manifest and init files, and also repair sessions, which is implemented inside GPAC, which is done in the media or dash level, where we request a certain HTTP request uh, to replace the a data packet that we lost. Session description is also a main feature, which basically is describing the multicast session, or the with an address, port, and other parameters. This is primordial for multicast, and we need to describe the session. In GPAC, we implement, this is an example here, it's an example of the session description example. Here is an example of the multicast configuration transport document, which is in the DVB spec, a replacement of the SDP protocol in 3GPP FLUTE. And it's very basic one here. The example is we have the address, the port, the location of the manifest file, which is mandatory to start the dash session, and the also protocol identifiers and other information. As I said, the main feature of FLUTE is the FDT, which provides a mechanism for mapping between the files and their objects. Also, I made a simple shot screen of an FDT instance, and we can see that the principal entry are the URI, or the file name, the file type, and also the TOE, which is the object identifier. So all objects with the same TOE is mapped to this file or object. We generally speaking, the working principles are: we segment the file to different source blocks, we add a header to each source block, and we have FLUTE packets. And we use one FDT instance per file. Generally speaking, TOE 0 is reserved for FDT table, so for the FDT. Next, I try to go through the service concept or channel concept in and media representation. So the basic example is we have a multicast group. It has only one service, and that service contains one channel, and we, in a way, transcode everything in this channel. So we have configuration parameters or files, typically XML docs, and audio, video in one channel. So this is we call in-band carriage. We have only one session, one service. Also, we can have multiple services and dedicate each session or each FLUTE session to one, either the control. We call it the control session, which we have the configuration, and also audio can be separated in each channel, or video, or even different media representation, different qualities for video could be assigned to different channels. So I will try in GPAC, we implemented FLUTE mainly in the DVB MABR implementation. I will we did implement this by May 2024, last May. We have a server and client, which means gateway support. We have low latency support. We have Reaper implemented, but and we have continuous tests, integration, improvement are undergoing. So I'll be setting a simple example. I'll share my entire screen if I can. And I'll start by try to move this one. So the first command is the server command, which takes an HTTPN manifest, so a session which is a dash session, and we forward it to an MRBR session using FLUTE. So it launches a session. The second, we have the client or the gateway, which will take this FLUTE and re-expose it as to HTTP, and we can launch the playback in the. Can you see the video?
Yes.
Well, so like I said, I did launch the server, the gateway, and the playback, and um, so you are hearing the noisy noise of the playback. But just what I wanted to show is the Wireshark uh, input. So we can see here that's um, I will yeah, I did hover over the main FDT, which will um, we send all the first FDT tables for the configuration document. So we have here the configuration document, which is the session description, the manifest, and the init file in one FDT, and we start receiving those files. Uh, yeah. Here there's the configuration document and then the manifest and the init file for audio and video. After that, we can see the use of the fake symbols here, and this is an example. We have the the first the object which TOA 12, and we have the FDT for it before, and we start receiving the file. So yeah, typically FTT has the content length, the TOE, and when we start the receiving the object, we have the mapping between the object and this file with the help of the FTT table here. So thank you. This is my presentation. If you have any questions, I'm glad to answer them.